It's here! The time has come! The TRS-80 Model 12 finally gets a modern expansion solution that it hasn't had since the 1980s when it was a new machine. In fact, not only does it get an expansion solution, it gets a better one. I'm TJB Chris, and tonight we're going to cover the new Tandy Emeritus 7-slot backplane for the TRS-80 Model 12, 16B, and 6000. Back in the 1980s, Radio Shack did offer a card cage upgrade for this machine, but of course most Model 12s didn't actually see that. And of course I'm joined here by my Model 12, which is now the unofficial mascot of the channel. That's because I'm pretty sure the Model 12 has appeared in more videos, either in a starring role or a supporting role, than any other system in my collection.
Not based on anything resembling a scientific study. No facts, data, or research was done to corroborate this claim. Actual channel mascot may vary.
And that makes it the unofficial mascot of the channel, at least in my mind. Anyway, let's take a look at why we're here and so happy tonight. Here's the star of the show. This is it, the Tandy Emeritus 7-slot backplane. And as we're going to talk about, this isn't just any ordinary backplane. It's not like the legacy Tandy one. It's better. So tonight in this video, I'm going to go through the backplane, what it is, what it adds over the legacy backplane, and we're going to look through the documentation, take a look at some auxiliary components that I got along with it, a little bit of a mail call if you will. I'm going to have some projects for the next few months. Then we're going to get to building this thing, and finally we're going to see the marriage of two projects. This Tandy Emeritus backplane is going to get married to the TJB Chris card cage chassis that I made last fall. For those of you watching way in the future, last fall means in 2023. We're going to finally marry these two projects together in what will be the stunning conclusion to months and months and months of work for both Tandy Emeritus and myself. Now, before I get started, I should let you know that availability information is still being determined, so I don't know exactly where or how you'll be able to get this just yet, but when I do, you'll see it here on the channel. In the meantime, I know that the board will be available as a build-it-yourself type operation, so let's take a trip out to the bench where we can take a closer look at the backplane, we'll talk about what's new, and we'll walk through the documentation. Join me. Welcome to the bench. My bench light here is off because it's wreaking havoc with the camera, so I'm going to apologize for the lighting. But anyway, let's take a look at what we got from Tandy Emeritus, shall we? And of course, you can see we already have the star of our show, the 7-slot backplane. And I've got a couple of other additional cards that are in fact related to the backplane. And then we've got an additional fun project. So let's take a look at each of these in turn. First off, the star of the show, the backplane itself. Again, 7-slot backplane, which after installation gives you 6 additional slots of expansion capability in your 12, 16B, or 6000. That's because the video card normally populates the single slot on the motherboard in those machines, which will now be replaced with the backplane. So your video card is going to be in one of these individual slots down here. Now, of course, you still have a whole lot of expansion available to you, and this backplane has additional features that are not found in the Tandy Legacy board. For example, we have LED lights here giving you power status. And I don't know about you, but anything with LEDs, lights, beeping, blinking, anything like that is automatically made better by the presence of beeping, blinking, or light up things. In addition, you'll see jumpers over here to the side of the slots. And this is the spots for jumpers here. These are very important and actually very useful. So, as you've probably heard me mention in videos before, the Z80 interrupt chain requires a constant path. Each slot must be populated from the bottom up, the bottom being the slot nearest the main board, in order to maintain that chain. If you put a card here in slot 1 and a card here in slot 3, but not one here, the interrupt chain will be broken and the cards won't work right. Furthermore, priority is actually determined by the slot order of the cards, which is why these machines, unlike like IBM PCs where you just stick cards wherever you want, you can't do that here. The order actually matters. All Z80 cards must be grouped together to ensure continuity. However, thanks to the Tandy Emeritus backplane, there's something of an exception. You'll see jumpers here that allow you to bypass an individual slot without moving your cards around. So say, for example, I've got a hard disk adapter, a serial port card, and a video card, and I want to remove the serial port card to work on it, but I don't want to have to shuffle my cards around. I can jump around it. And that allows me to essentially bridge the gap in the missing slot, bringing the interrupt chain and bus master up to the next slot for me, so I don't have to populate a card or move things around. This is very handy. And there are other features. My background on the various interrupt and bus chains on this thing is primitive at best, so I'm still learning about this, and it's definitely a place where you can get your head turned around, just in what I know. Anyway, in addition, you'll notice these two wonderful little bus extensions here. The Z80 bus, this 80-pin extension, consists of two 40-pin connectors which actually use standard IDE cables, 40-pin IDE cables that you used to find in 90s PCs all over the place. And you can use this to bring the bus out of the card cage and make it much easier to diagnose or interface new hardware with the bus. And in fact, that complements very nicely with this card right here. This is the test fixture. This is 2 additional slots, which are connected via that same extended bus, out to, and I've got it upside down here, out to a place outside of the machine. So you could run this out on your bench or someplace, well, with the cables coming back to the backplane, and you could plug your cards in here for diagnosis, testing, or development. And this is meant to stand up like this and has a 3D printed fixture that goes along with it that we'll talk about when we build this card. We won't be building this in this video, but this allows you diagnostic extension beyond the card cage itself, and this is going to make things much easier. Working in the card cage can be quite difficult or require riser and extender cards, so this gives you a lot more flexibility. And just like on the backplane itself, you have the ability to jump past the individual slots. You can chain past them if you don't have 2 cards, and there's an optional socket for power if you want to extend power out to it. So this is the test fixture, and also complementary to this is the Diagnostic Spacer. I can imagine this being especially useful in situations where the machine is together, so I may not be able to get to the ribbon cables here, but I wish to extend the bus out of the machine. So, for example, I have my 2 connectors here, my 2 40 pins. I can plug this into one of the slots, run the ribbon cables out, and connect it to the test fixture, and now, without taking the machine apart, I've found a way to extend the bus. The Diagnostic Spacer also has jumpers on it to allow you to jump past jump the interrupt chain and bus master chain past the existing slot you're in, which is really nice if you're using this with the legacy Tandy backplane. So if you don't have the Tandy Emeritus backplane but want to use the test fixture, consider the Diagnostic Spacer. But either way, it's handy, and I'm going to be building this in the same video in which I build this, because they kind of go together. And finally, we've got one more set of boards up here. These 2 go together but are for different machines, and this is the Z80 CPU replacement board. This allows you to replace a Z80 CPU, put it the right way, with a 180. And there are 2 versions of this board, with the Z180. There are 2 versions of this board, one for the models 12, 16B, and 6000. You can see the hole for the capacitor there. And one for the models 2 and 16, which don't require the hole and have a smaller form factor. And these take the place of the Z80 CPU. You remove the CPU and insert this populated card. And that's what we've got from Tandy Emeritus. So tonight, of course, we're going to be focusing on the star of the show, the 7-slot backplane. And I'm going to start getting it together. There's a lot that has to go on here to get this thing functional. We've got, as far as I can tell, 762 individual solder joints, 560 of which make up the 7 80-pin slots here. Another 80 over here for the bus extension, various capacitors, and the jumpers and things. And we've got resistor networks and things like that, LEDs. So there's going to be a lot to do on this. In fact, as you're watching this video, you're probably going to notice my clothes spontaneously change. And that's because I'm not going to get this done in a day, folks. Now I think we're going to pull up the documentation, talk about some caveats in assembling the board, and some other bits you need to know before I get cracking. And here we are, all set up and ready to go. First and foremost, most important, documentation. This documentation was written by the designer of the backplane board, and you should read the entire thing before you get going, before you start. Don't just open to page 1 and start putting stuff together. Read the thing. I don't know about you folks, but I'm the kind of person that likes to know what's going to happen next, because it makes it a whole lot easier to figure out if I might be doing something wrong. When stuff doesn't look like that thing I saw on the next page, but I know the next page is right there, I can maybe fix it before I wreck it. So you should do the same. Read the documentation. It's thorough, it's excellent, and very well written, and it's got some entertaining pictures all throughout, so I highly recommend it. And of course, the first page of the documentation beyond the cover is the bill of materials. And the bill of materials includes manufacturer part numbers and Mouser or other supplier part numbers where necessary. And you can see I have a whole lot of bits on the bench here ready to go. The one thing you're not going to be able to find at Mouser are the 80-pin 2x40 amp sockets, the card edge slots. There are a couple of places you can get those. You can buy actual amp connectors from a place called Surplus Sales in Nebraska. I'm not endorsing them. I didn't get those free. I paid for those, so this isn't sponsored. I can say what I want. But I can tell you I've ordered from them a couple of times, and I've had pretty good luck. They ship quick, and the parts are as described. Their website leaves a little to be desired, and searching on it kind of stinks. But hey, you know what? I'll trade that for reliability and availability of parts. One important note about those things are about $9 per slot. You might be tempted to cheap out and skip over them, and well, you could technically do that. Do you want to have to try and source them down the road when you decide you need that 7th slot that you just didn't populate? I know I don't. So go ahead, and if you're going to do this, do it right. Buy all the parts. There is a knockoff part available. I'll put the note up on the screen and a link in the description. But I'm told that that part isn't a perfect fit. You might have to do a little finagling on it. I don't have direct experience with that. If you can get them from surplus sales for $9 per part, that's a small price to pay for an insurance policy. And if you're going to stick one of these in your Tandy computer, doesn't your TRS-80 Model 12 deserve anything but the best? I don't think it does. I think it deserves the best. But if you can't, well, go to that other place I linked in the description. My soldering iron is all warmed up and ready to go, 350 Celsius. So I think it's about time to break out the documentation. I've already read it once, and we're going to start putting this together. So first up, of course, I've got the documentation up here. I've got the bill of materials up. Take a good look at it. Of course, the PDF is on my GitHub and will be available when you get a hold of the Backplane. But just make a note, make sure you have everything you need. You have everything up in advance. Part numbers are there for Mouser for the most part, and of course surplus sales for the amp connectors. So you're going to want to get a hold of those. Make sure you have everything double, triple check. The resistor networks for the top, the various resistors are socketed. You're going to want to socket those. It's much handier because you're going to need to socket those if you're going to want to make use of the expansion bus. And actually, let's take a look at the next page here. I'm actually going to go through the rest of the enhancements because I didn't really go through them all. One of the important things about this is a 4-layer board. So you actually get better power distribution and you're going to get some noise reduction. Of course, we've got the LEDs, we've got the Z180 I/O bus, we've got the pluggable resistor networks, which I just mentioned, and of course the 80-pin sockets and jumpers to jump the interrupt chain and bus master chains. So those are great. And of course, one important caveat in the first one, we're going to get to building it. These 3 capacitors are not oriented the same way. The 12-volt capacitor has a orientation that is opposite of the other 2 above it, the minus 12-volt one, I should say, even to the point where on the board it does have a little exclamation point there. So if you're paying it all attention, you should be able to see that. Let's hope I'm paying attention when I go to put it together. And of course, you'll get to meet Sizzle. Sizzle is the dog, and there's a whole lot of great artwork. I loved the artwork through this. Okay, first things first, we've got to put the capacitors on, and we've got to do the sockets for the resistor network. So let's go do those now. And there we go. Sockets for the resistors, and we've got the capacitors installed. Plus 12 and plus 5 are faced in the same orientation with negative on this side of the board, and minus 12's negative is on this side of the board because of the reverse polarity. So I think we've done a pretty decent job. I don't know how you'll be able to see it on the various solder joints. All right, I think next I want to start with the sockets. I feel like these are the majority of what I have in front of me aside from the bus extension, and are actually going to be some of the harder and slower going. Oh, and the power connector. Let's do that next, actually. All right, power connector is on in the correct orientation. Now, as the documentation recommends, I'm going to snip the backs off of these just to avoid the potential of shorts. There's another thing we're going to do later to deal with that, but let's do that now. All right, power connector installed. I think next we are now actually going to start with the slots because I have 560 pins to do. I'm going to do this slot and then this slot, so that stabilizes the board, and then the others should be easier to kind of set in there. At least that's what I'm thinking in my head. Sometimes best laid plans of mice and men, but we'll see how this goes for me. Let's get to it. And there we are, the completed product, standing up against my shelves here. So we have, of course, our 7 80-pin card slots. We've got our resistor network sockets with resistor networks populated, capacitors, resistors, LEDs, because of course, when the design includes LEDs, you must put the LEDs in. Anything that lights up, beeps, or blinks is better. Of course, the Z180 bus extension over here, power connector, more of the capacitors. And on the side here, I hope you can see, I've got my jumpers for extending the bus master and interrupt chains up to each of the slots. So we're good there. And of course on the back, just so you can kind of get a glimpse of what we got on the back here. One-handed because I got the camera in here. It's pretty straightforward. I've got the resistors for the LEDs here. And contrary to what that may look like, that one resistor on the left, that 5.1K, is not actually touching that negative terminal there. That resistor's form factor, as you can see, was bigger than the others. I didn't expect that when I got it, but I guess I wasn't paying close attention. And of course, we've got these capacitors. Now, one thing I should note, and the instructions note this as well, the silk screen has, for example, these resistors and these capacitors on the back side of the board but as indicated in the instructions, you don't necessarily have to put them on that side. Since that's where the silkscreen had them, my personality is the kind of person that I put the things where it says you put the things. So we're going to see how successful I was in this episode of TJB Chris Follows Instructions. When we go to the other room, and we're going to talk a little bit about this particular backplane, the Revision B. We're going to compare it to its friend here, the Revision A, which I also have because there's a couple of important caveats when it comes to installing this, especially around insulation. We're going to talk about some other concerns in terms of insulation because there are solder joints and components in places where the legacy backplane did not have them. So we've got something in the works for that, and in fact the 3D printer is hard at work on that right now. And then we'll get to taking my Model 12 apart, getting the Tandy legacy backplane out of there, getting this card installed into my card cage, and then we'll try it out. Before we do that, off camera, I will be taking the meter to this real quick just to make sure there aren't any direct shorts or anything like that, anything I've got to cover up. And I'll take one last look at it under my magnifying light here just to make sure that I haven't really screwed the pooch. I'd hate to put this into my Model 12 and destroy it because of a short or some really rookie mistake that just ruins a Model 12 along with it. I don't think I did, but better safe than sorry. Okay, we'll see you in the computer room. Back in the computer room, I've got two backplanes here on the desk, as you can see, one populated and one not. But other than that particular difference, something else is not quite the same with these backplanes. So I'm going to talk about that and these two pieces of 3D printed plastic behind them. First, let's talk about the differences between these backplanes, or at least the ones that matter for this discussion. So other than the fact that the one on the left isn't populated, this is a Revision A backplane, and the one on the right, which I have populated, is a Revision B backplane. Pretty much any orders that come in for these backplanes should be at least Revision B. I don't expect you'll run into Revision A, except you might come across some early ones down the road in machines. So if you're watching this in the future, 2034 or 44, yeah, right. But if you are, and you want to know why there's some differences or what the differences are, I'm going to tell you. The main difference as it pertains to this video, we'll just get the glare off of here, is that, as you can see, A is not quite as tall as B. Why is that? And how does it relate to those pieces of plastic that are on top of those backplanes? Let's talk about that. The difference actually is going to come down to whether or not you need this 3D printed part and whether or not you are using the Tandy metal card cage chassis. If you're using my 3D printed chassis in anything other than metal, which would cost you $2,200 the way I designed it when I last checked, so I don't think you're going to be doing that. If you're using my backplane, it's probably some sort of plastic, PLA, or other material, and therefore this is not going to apply and you won't even need this. However, if you're using this Revision A backplane along with the Tandy metal card cage chassis, you're going to want that part I just threw behind me because it's going to provide a very important public service. Specifically, I'd like you to take a close look at the amount of space between these traces, where you're going to have a bunch of solder joints, and the board at the top of the backplane. The problem here is the Tandy metal cage has a metal overhang, which hangs back over the back of the card, just like the picture you're seeing on your screen now, blocking my terrible attempts to mime it by hand. If you notice, that metal cage may come in contact with these resistor networks, shorting them out. The difference between this backplane and the Revision B backplane is a pretty simple one. As you can probably tell, there is more space between the top of the backplane and these contacts. So what should happen is the metal chassis should terminate here. Now, I'll tell you that you may want to use that 3D printed insulator even when you have this backplane, just in case there are any shifts, bends, or anything else that happen. And as an insurance policy, I mean, what is, 7 cents in plastic really going to cost you? So that should pretty much do it for the Revision A, Revision B differences that we're going to be concerned about. Everything else should be pretty much the same electrically. As far as I understand, the boards are fairly similar. The big thing is going to be the insulation requirements. And again, you may still want them on the Revision B backplane. But wait, there's more, as Billy Mays would say. You also notice that this wonderful 3D printed piece before, sitting on my table. What the heck is this? Those of you who've read the documentation may already know that this is an insulator. So on the back of both of these backplanes, you'll need this for both revisions, you'll notice that there are additional solder joints and contacts where there weren't any before. And the Tandy backplane, the legacy one, didn't have anything here, so you didn't have to worry about any metal pieces behind them. Well, now with this backplane you do. So this cover goes conveniently on and uses two of the mount holes actually use the card cage mounts, but the other one here, there's a third one over here, that allow you to block those solder joints and prevent unintentional contact with the metal chassis in the Model 12 16B or 6000. This is a highly recommended item, and I'm going to be using it when I install it into my Model 12 because I want to make sure I don't have any issues with shorting out, flexing the card cage while you're working with it. If the machine's on and you're poking around, you could flex it and you might be close enough. Also, it's worth noting, and the documentation notes this, these solder joints here for the power supply stand rather tall. I've snipped these down a bit so they're not quite as bad, but you could still run into issues even if you do snip them down. So do yourself a favor, 3D print this piece or try and get a hold of it because you're going to want it. All right, now that we've covered the differences between the backplanes, I think it's time to get this Model 12 apart. We'll take out the old card cage and backplane assembly with a legacy Tandy backplane, mount this nice new Revision B stuffed backplane into my card cage, and then we'll install it into the Model 12 and we'll try it out. And hopefully we have success. Let's get this machine apart. And Model 12 disassembly complete. And you can see my TJB Chris card cage here, if my camera decides to play nice and focus. And the legacy Tandy backplane, we'll take a closer look at that. So now I'm going to remove this, and we're going to put the new backplane into this existing card cage. Hey, look, we're back at the bench briefly. I figured I'd be remiss if I didn't show you the differences between the Tandy Emeritus backplane and the legacy Tandy backplane, considering that they're both out of the machine at the same time this one time. And the differences are pretty obvious looking at them, but I figured I'd cover them anyway. And I'm sure I'm going to miss some, but let's go over the major feature differences. First off, of course, is the Z80 bus extension that you can use to bring the Z80 lines out to, say, this test fixture here, or otherwise. But that is something that, of course, you don't see on the Tandy backplane. There's just, well, nothing. In addition, you'll notice we've got our interrupt and bus master chain jumpers to bring the bus up to each of the next slots without having to put a card in the respective slot. And of course, the Tandy backplane has no such thing. Next, of course, there are, LEDs. These are very important. And of course, on the Tandy backplane, wait for it, no set LEDs. Bummer. In addition, the Tandy Emeritus backplane is a 4-layer board, and I discussed that earlier, so that is one difference between that and the Tandy backplane. And some of the improvements that were glommed on or otherwise bodged onto the Tandy backplane were made permanent on the Tandy Emeritus one. So for example, here you can see we've got these bodged on resistors. Those are capacitors, folks. Those are capacitors, not resistors. But either way, those bodged on capacitors, and here they are included within the design of the backplane with through-hole mounts, as you can see here. So those are the main differences between the two backplanes. I feel like I'm missing one, but I'm not. Oh yes, actually, one other one is, of course, these resistor networks are socketed, and that means if you extend the bus out, you can transport them over to the test fixture. So those are the big differences between the two. Like I said, I'm sure there are others that I'm either forgetting or not aware of, but the big ones, of course, are expansion, LEDs, interrupt chain, and the pluggable resistor networks. So now I'm going to get this thing mounted up into the machine, and we're actually going to do a power test before I connect it to the Model 12 bus. This way, if I have any problems I didn't already catch with a meter, or my repeated inspections under the light here, at least the power supply will freak out and I won't just blow up the motherboard. Let's go back to the computer room. Back at the Model 12, the backplane is connected to power, but as you can see, it is not connected to the main board of the Model 12. And I have in the Model 12 the video card in the expansion slot with the monitor connected, and that's because I need the load on the power supply. I want everything to be as close as possible, and for that to happen, I need the monitor to be connected. But here's the thing. You can't run this without a video signal. It will cause problems. You can destroy them, as far as I know. And so I'm going to have to feed it a video signal. So what we're going to do, put the camera on the other side here. I'm going to hold this up and power the machine up with the backplane connected to power, but not to the bus. If everything goes well, I'm going to give it one more once-over under my magnifying light, and if everything looks good, we're going to install it and see what happens. All right, let's try this. Okay, here we go. Moment of truth. I've got the backplane off to the side here connected. I've got the video card here. It's not touching anything. The machine is plugged in, and I guess now I'm going to try and just touch the side of the slot here so I'm not sticking anything. And that sounds good. And we have an insert diskette prompt. That's excellent. And I don't know if you can see this. Do this. you have the 3 LEDs on the backplane. And if you can't see that, I'm sorry, but I have my LEDs lit up, so I have +5, +12, and -12 volts. All right, I'm not going to do this precarious business any longer. We're going to shut you right off now. And now, let's mount it and see how it works. And here we are, Tandy Emeritus backplane installed. You can see I have my backplane cover there. You may notice I have washers under some of the screws. One thing I noticed on this, the screw holes are a little bigger than the Tandy backplane, so you're going to want washers. These are the ones I had on hand, but they're not going to be permanent because these cardboard washers aren't going to hold up over time. So I'm going to want to get nylon washers. I went back and forth on using metal, but I'm afraid metal floating around in here, if anything comes loose, it just has the potential to damage the machine. So I'll have to keep an eye on the nylon, but I think I like it. Your mileage and opinion may vary, but these washers can't be permanent. They're cardboardish. But either way, it looks really good in there, of course. Now let's take a look at the other side. And here we are, backplane installed again in my card cage. It's like the marriage of two projects. And you can see that wonderful Tandy Emeritus silk screening there. In fact, the names of the members of Tandy Emeritus in there. And of course, I have my video card installed and my 12 and 15 meg hard disk interface card installed in the first slot. I've got my video rigged up. I'm trying to do this without getting into the light. I've got my power cord on that power splitter I built when last we visited this machine. Everything is wired up, and I think we're ready for, I dare to say it, a smoke test. We've already tried the backplane out without plugging it into the bus. Now let's see what happens when I plug it into the bus. Best case scenario, I get an insert diskette prompt, no bizarreness, and the thing lights up and all the LEDs are on. All right, let's do it. Okay, here we are. We're going to try this out. One last look at the connections. I've got video, the sockets are in, card cage is seated, everything's screwed down, power connectors are installed the correct direction. I guess it's time to see what happens. 3, 2, 1. And it looks like we have liftoff. Let me come around and take a look. We have an insert diskette prompt. I'm just going to take you right off the tripod here. Look at this. We are powered up on the Tandy Emeritus backplane around back. Let's take a look. A thing of beauty is a joy forever. And of course you can see the LEDs making the camera work for it there. But those are the 3 power LEDs for +5, +12, and -12 volts. We've got our cards in place. Obviously the bus is working, the video card is working, and everything is good to go. What a great moment. I'm so excited to see these two projects come together and create a modern card cage solution. Expansion is here for your TRS-80 Model 12, and enhanced diagnostics are here for your 12, 16B, or 6000 should you choose this backplane. So let's actually get this machine back together and we'll do a little bit of a debrief. And there we are. This Model 12 can now see its full potential in 2024 using a combination of the Tandy Emeritus backplane and my card cage chassis. And of course that means that the market for expansion cards for the 212, 16, 16B, and 6000 systems are going to see prices go up, 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 because now we're going to have additional competition for all of you building backplanes out there and making your Model 12s expandable. But that is going to be totally worth it, and it's going to make the community better. And it is so exciting to have an expansion solution and to be able to unneuter these machines 40 years later. And so with that in mind, coming up on the channel, probably not right up, but down the road, I do plan to build the Test Fixture and the Diagnostic Spacer and demonstrate them here on the channel, as well as one of those Z180 boards for the 16B. So until then, I will raise a glass to expansion capabilities for the Model 12, a successful project, and all of you for watching me. Thank you for watching and for following along in this journey. There will be more to come, but until then, stay classy, and here is to the Model 12 and expansion possibilities. Cheers, and thanks for watching.